Hi, I'm Max. This is the second day of the Collisions and Explosions summer camp, and today we're going to be doing the classic baking soda and vinegar reaction, and I'll be showing you how it works and explaining some of the stuff behind it and why it's such a cool reaction. So on the left, I have a few tablespoons of baking soda, and on the right, I have vinegar that has red food coloring in it, and a few drops of dish soap to make it all bubbly. And then when I pour the vinegar in the baking soda, you can see the reaction starts really quick and it all bubbles up. And a lot of those bubbles are from the baking soda just kind of holding everything in. Baking soda and vinegar is actually a complex reaction because it takes place in two parts. First, you have what's called a double replacement. This is where a few of the atoms in each molecule decide that they just want to go to the other one. And there's two molecules, and they just swap a few atoms. It's pretty neat. So, you have this one right here, which is the sodium bicarbonate, okay, baking soda. And right here, this is the acetic acid, the vinegar, okay? So you add these two, the little plus, and they turn into sodium acetate and carbonic acid. And interestingly enough, carbonic acid is actually in a lot of sodas and soft drinks and stuff like that. It gives it, it makes it kind of like hurt a bit and burn when you drink it. Yeah, that's what happens. And it's from putting all the, so when you make it all fizzy and bubbly, it gives it carbonic acid. And then what happens is in this, so then you have these two molecules left, except the carbonic acid is actually not stable, which means they really want to break apart. So you have what's called a decomposition reaction, okay? And that means that they're just going to split apart, like the Beatles. So they split up into H2O, which is water, and CO2, carbon dioxide. And so all this CO2 is what makes it bubbly. And you can see I put in dish soap into the vinegar mixture, so it would keep all the bubbles and make this huge foamy pile. If you didn't put dish soap in, most of the bubbles would kind of pop pretty quick. But with the dish soap, you get this nice bubbly mixture, and it's pretty fun. But these numbers and letters are all pretty confusing. And I think it'd be cool if we drew them all out. And so this sodium bicarbonate can actually be drawn out as sodium, which is represented by Na. Then you have an oxygen atom, which connects to a carbon atom, which connects to an oxygen-hydrogen pair. And these two are really tight. It'll be really difficult to separate these guys. And then this carbon atom is doubly bonded to this oxygen. And then this guy is just like touching, like these guys are just like friends. And so you have this. And then you have the acetic acid, and you have a hydrogen bonded to a carbon, which bonds to another hydrogen and another, and then over here it has another carbon who is also doubly bonded to an oxygen, and he's also singly bonded to this oxygen because this oxygen is bonded to a hydrogen. And so you have this one as well. And then when you combine these, you can see they all rearrange themselves. So what happens here is now it's all visual, so it's very easy to understand. So this guy right here, this Na, you can see he swaps over to the other one. So this Na actually swaps out with this hydrogen. Yeah. And they just kind of swap places, but they end up doing different things. So your final product ends up being, you have another OH group, doubly bonded, or my bad. You have this OH group single bonded to this carbon with another OH group right here, and this dude double bonded with oxygen. And then you have the other component, which is this one. And so right here, it's the same kind of thing. You have the hydrogen and the carbon and the hydrogen and the other hydrogen and then the other carbon and the oxygen like here. Then you have this oxygen. But because he no longer has a buddy over here, he doesn't have that H, he gets magnetic. Okay? He gets this little minus sign. But lucky for him, this Na, the sodium, has a plus. So they're attracted to each other. So this Na just goes right here, and they just, yeah, attract to each other. And then that's what happens. Except this one right here is unstable. So you see it breaks up here. So, I'll draw it out again. So you have this carbonic acid, and it breaks apart into water, which has a big O in the middle, and then two hydrogen friends. Oopsie. On the side, and carbon dioxide, which has two oxygens, which are doubly bonded to their carbon friend. And that's it. But as you see, there's some things that don't quite align here. Actually, in this one, everything aligns just fine. You can see you have 3 oxygens here, 3 oxygens, 1 carbon, 2 hydrogens, and 2 hydrogens. Oh, and the other one aligns fine. So there are some reactions where you need more of something to get less of something else. Like, let's say this guy, instead of needing just 1 Na, he needed 2 Nas. Okay? That would mean you need 2 of these guys to get those 2 Nas. But luckily in this case that doesn't happen. So you can just get 1 of each, or one of this, 1 of that, and it makes 1 of this and 1 of that. That's pretty neat. Thank you for watching. If you have any questions or any comments, you can just hop on the Zoom call in the link in the description, and yeah, just ask them. I'll be there.